This conference will now be recorded.
Hello, everybody. Jordan Garth here with the National Weather Service Office of Observations. Thank you for joining us for the Satellite Book Club Seminar Series. This is session number 176. The title of today's presentation is GOES-R to GeoXO, NOAA's Geostationary Satellite Systems Today and through 2050. Our presenter is Pam Sullivan, Director of the Office of GEO Observations. Our facilitator is Sharon Sullivan, aviation meteorologist from the National Weather Service, CWSU, in Albuquerque, New Mexico. As you just heard, this session is being recorded. There will be an opportunity for Q&A after the presentation. Please post your questions in the chat and we will field them in the order they are asked. If you have not signed in using your full name, perhaps you're using an office account, please note your name when asking a question in the chat. That way we can follow up if necessary. We are always looking for future presenters. Please contact our Tower S team if you would like to present. Perhaps you had a recent presentation at the AMS annual meeting that would also be good for this audience. And the training team can help create training materials that may be unavailable or you may be unaware of. Ross Van Til can help with that. I'd like to thank our Tower S team, Kashad Bowman and Emily Maddox, the Office of the Chief Learning Officer, the GOES-R JPSS programs, our facilitator, presenter, and all of you for being with us today. Pam is our guest today. She leads the development of NOAA's geostationary satellite systems as Director of the Office of GEO Observations. She manages the Geostationary Operational Environmental Satellite R Series and Geostationary Extended Observations GeoXO programs, responsible for the development of the spacecraft, instruments, launch services, and ground systems. Pam joined NOAA in 2018 after 27 years with NASA, where she contributed to multiple spaceflight missions, including the Joint Polar Satellite System, James Webb Space Telescope, Hubble Space Telescope, and the GOES I through M, NOP, and R series projects. Early in her career, Pam served as a United States Air Force officer supporting Space Shuttle and other manned spaceflight missions. She holds a bachelor's degree in aeronautical engineering from M.I.T. Pam, welcome back to the Satellite Book Club.
Great, Jordan. Thanks so much. It's great to be back with the book club here as we approach the GOES-U launch. So I'm going to go through charts that I did present at AMS, but I've also added a couple special charts that I thought this audience would be interested in. So again, thanks for joining us. Next. So I thought it would be nice as we're coming to the end of the GOES-R series to kind of do a little bit of a retrospective. And when I say the end of the GOES-R series, I know it's not the end for the forecasters, but you know, as we come to the end of the development phase and a lot of the program team is, you know, looking a little backward at all the work that has been done. But I just wanted to celebrate that the 7 years that we've had GOES-R observing already have been a pretty astounding 7 years. Just some numbers there. We've the satellites, since they've been observing, have actually seen 135 Atlantic Basin tropical storms, 112 deadly tornadoes, more than 300,000 wildfires, and 134 disasters totaling $1 billion or more, with total damages over $1 trillion, and not to mention, you know, the warmest years that we've seen on the planet. So great job by GOES-R and team, and looking forward to those continued observations into the 2030s. All right, so let's see, as click one more, I think I've got animation in there. Yep, thanks. So just an update on the satellites that are on orbit. 16 continues as our GOES East satellite. There is a thruster anomaly that hopefully will be of no impact to the users, but we are a little bit babying the system there. We are looking at a concept actually of using the satellite in a higher inclination orbit. If we get to the point where we're low on fuel, we might let the satellite drift a little bit higher. This concept has been used with previous GOES-R series, previous GOES series. So we're looking at what it would take software-wise, et cetera, to implement that for GOES-R if needed. GO17 is our in storage satellite. GOS18 is our GOES West satellite. All the products are, almost all the products at full maturity level. And then our ground team has also been very busy. We actually completed a system-wide server replacement. More than 1,000 servers had to be replaced. And then we're also working on new products, one of which you can see there up top, the new cloud cover layers product. And we're actually working on trying to get the product generation from where it is right now with on-prem systems into the NESDIS cloud. So we've got a prototype project going right now and hoping to make that operational over the next few years. This audience probably gets its share of ABI data, so we can skip over these. I'm sure everybody is familiar with the Hurricane Dora, and the next one was the Maui wildfires, which GOES18 had a good view of that unfortunate event. And then the next one was about the wildfires and the very unusual, conditions that we had up and down the East Coast from them last year. Again, GOES East had a good view of that. Next. And then your average April in Texas with a storm producing very large hail. Next. Okay, Otis is working. Anyway, so this was Category 5 storm again. This audience probably very familiar with, this was one of the storms that did the very rapid intensification towards the end. Anyway, so just some highlights from the last year. Next. So something new that may not, everyone may not be aware of. Some researchers at Harvard have recently been using ABI data to look for methane leaks. So this is an example of one that they found just, I think this is northern Mexico. It's not the only one. There's been several that they've been able to detect, and it has to be a very large methane leak. But still, it's important to be able to detect these because when they happen, there's a lot of methane being contributed to the atmosphere. And so seeing these, knowing that they're happening, being able to tell, it's generally a facility or sometimes it's a transport line that develops a leak. So it's very important to be able to tell folks that it's happening so that the folks at the facility can actually do something about it. So, and again, this was research done by Harvard University. NOAA is actually moving to try to put this into an operational capability. So interesting application that we hadn't foreseen before. Next. All right, which brings us to GOES-U, the last of the GOES-R series. We are wrapping up all the things that happen to get the satellite ready to launch. We've had the launch vehicle, CDR, completed last year. The satellite's now gone through all of its environmental testing, the shaking and the baking that we do to make sure the satellite will survive space. Pre-ship review happened last November. We actually did the operational readiness review last month, and in the picture there you can see that the satellite was actually shipped. It was loaded onto a C-5 aircraft at Buckley Space Force Base and flown down to Kennedy, and it's currently now in its pre-launch preparations at the Kennedy Space Center. We've got a couple more milestones coming up, the key decision point in March. The launch is still on track for April 30th. Targeting a first public image, probably June, July timeframe. We expect to complete all the testing and do the handover to OSPO for operations by December. And as of January next year, we hope this one will be operational as our GOES East satellite. And if you're wondering why it's going into service as opposed to into storage, that's because it's got a brand new instrument on it, the compact coronagraph. You can see the picture of it there below. It's got this kind of cool aperture, and it's designed to look at the sun. It actually blocks the sun in order so that it can see sort of the halo area around the sun. And that's because it's looking for coronal mass ejections that are coming out of the sun that might be coming towards Earth. And so this is a capability that we've not had operationally before. This capability is currently provided by a very aged NOAA and ESA satellite called SOHO. So when GeoXO goes into service, this will be the first time we get these measurements reliably from a NOAA satellite. And anyway, because we want that compact chronograph to go into service, GeoXO is going into service, and then GOES-16 will become an on-orbit spare for us. Okay, next. All right, some more details for those that are into it. This is how GOES-16 will transition to GOES-U or GOES-19. And the blue, where it's highlighted blue, that's where the satellite is operational. So GOES-16 will be operational basically through the end of the year. And on the right, you can see the activities for GOES-U, GOES-19, with a launch on April 30th. We'll go through the post-launch testing and the post-launch product testing through until November. Then we've got handover readiness reviews. We will be drifting the satellite over so that it is adjacent to GOES-16. They'll be operating at roughly the same latitude for a short period of time. And then when everything is ready to go on GOES-19, we'll throw the switch, and GOES-19 will become the operational GOES-East satellite nominally in late January. And then GOES-16 will be moved to the 105 West location and again be in storage there. All right, next, this is possibly the cutest slide I will ever show in a presentation. In the background there is the GOES-U satellite. This is at Lockheed. They have a Friends and Family Day, a thing where the workers can bring in their families and show them the satellite. And these particular GOES-R fans, the tallest one's a little hard to read. She's wearing a GOES-R shirt. The middle one's got a GOES-S shirt on. And then the very spunky little one has a GOES-T shirt. And the family does tell us that they are in fact pregnant with a fourth child. So they'll have a complete set. All right. All right, so speaking of families, we just updated our history of US GEO satellites going all the way back to the mid-60s with the ATS satellites through the GOES-R series. And of course, we do expect our GOES-R series to be operating into the 2030s. And that, of course, brings us to what's next. So, which, of course, is GeoXO. And we've talked about GeoXO before. Here, the Phase A efforts are now complete. So all the studies that we had with instruments, spacecraft, those are all wrapped up as in June. And we're really focusing right now on getting the contracts in place with the development organizations for the instruments and the spacecraft. We have actually awarded the Imager contract that went to L3 Harris. That was announced March of last year. Ball Aerospace was selected to develop our sounder instrument. That was in September. We did actually have a contract protest, which was resolved by GAO. And then the protest, as per the process, they are allowed to continue that protest to the next level, which is the Court of Federal Claims. And we are actually working right now on resolving that particular case. So, but in parallel with that court case, the instrument development has started. We are working with Ball. And so things are good with starting the sounder development. And we will very soon be awarding the remaining contracts. The Lightning Mapper is targeted for the announcement being late this month. The Ocean Color instrument should be announced in March, the atmospheric composition in May, and then the spacecraft is planned to be announced in May as well. So with that, we'll have the whole flight development team on board, and with that, we would then move on to our next major review for GeoXO, which is the mission definition review, and then the key decision point B, which we'll do late this year, maybe into 25. But anyway, so good progress there. Next. And just some highlights. What you'll see in the GeoXO imager, a couple things are new. We've got two new channels, the 0.91 micron and the 5.15 micron. These are both channels that will help with detecting very low level water vapor. There's been, studies already of kind of what they'll be able to see that we can't see, and so there's some interesting work done there. You should definitely have someone come back to the Satellite Book Club and talk about GXI for sure, and some of that work and what's coming. The other major change that'll be, I think, more evident for non-meteorologists is just the improved resolution that we're planning. So the Viz channel, planning to go down to a 1/4 kilometer. Many of the other channels that are 2 kilometers now, planning to go down to 1 kilometer. And you can, see the example of the improved resolution there with Nantucket Island. And on the next chart, there's an animation that's been done of the difference in what we expect the GXI imager to look like compared to the GO-16 ABI. You can see, you really can see the fires starting earlier. You can get a much better sense of where they are in the spots. And so anyway, so that'll be a big improvement for those that are trying to track wildfires. Next. All right, and our sounder, I know a lot on this call are probably very much looking forward to having the GEO sounder. And of course, we think of it mostly for numerical weather prediction, and that the animation there from EUMETSAT, gives you that sense of that really very dense 3D cube of data that we're going to be getting from the sounder that will go into the NWP and improve forecasts. And in fact, Satellite Book Club should have someone talk to them about the GeoXO sounder, because there's been a lot of work done about the applications and how much forecast would be improved with the sounder. So I'd recommend that as a future book club as well. But in addition to the NWP application, there's also applications for nowcasting. And an example of that, might be the total precipitable water. A forecaster could be looking at this data in real time and helping assess a storm or flood, flood likelihood, looking at sounder data in real time. Right, next. And a little bit of an update based on the ball design. Just to give you a sense of what that's going to look like. It's going to be scanning a slit that's oriented in a north-south direction. The slit's going to be about 3.4 degrees of north-south Earth view, and that will scan across from west to east over the Earth. So that'll be roughly 5 swaths of scan to cover a full disk. The ball design is actually quite speedy. It should be able to cover that full disk in less than 30 minutes, which is about twice as fast as what the spec is. And of course, that scan pattern, probably won't be that full disk all the time. We'll probably have some pattern that has full disks interspersed with super regional and meso scans, but the speed of the ball design really, helps enable, I think, a lot of different options in that case. And then just to note that the ball design again has 1,500 mid-wave channels and more than 1,000 long-wave spectral channels. All right, so some other instruments we're looking forward to. Atmospheric composition is one of the new instruments. This is the instrument that will be paired on the center satellite with the sounder. And the data here is from NASA's TEMPO mission, which is just starting to produce data. I know some of the NOAA team is actually getting the data, looking at the data. And the atmospheric composition instrument has specs that are very similar to TEMPO, so we expect our data to look very similar. You can see in the lower movie the resolution there. It's kind of a 5 kilometer-ish pixel, and so you can see kind of the neighborhood level of imagery that you can get. And of course, this is going to be looking at a lot of different atmospheric chemistry things. You can see the formaldehyde and the nitrogen dioxide in this particular movie. Anyway, so that's another new capability we're planning next. And I know this community isn't as excited about the ocean color, but I think it's going to be a really capable instrument. So I'm guessing it may have some applications that the weather community finds of interest in the long run. But in the meantime, we are selling it really on the oceans and the fisheries kind of applications. The data here is from South Korea's GeoXO instrument. The top is looking at harmful algal blooms. This is one thing, of course, we want to do with our ocean color instrument. And you can see from the map there, it can look at the chlorophyll. It can determine from the color which of the blooms are actually dangerous ones. This is a loop over one day, so you can see that the harmful algal blooms actually change a lot, from morning to afternoon in this particular movie. So this is information that does benefit from having that rapid update from GEO. And then the bottom movie is a measure of water clarity. This is something actually that the US Navy has told us they're very interested in understanding. They have applications where they really want the water to be clear when they're doing, diver operations, when they're, working with mines underwater. You can understand that they want clear water for that. They've also told us that there's applications where they really want it to be not clear. So for some of the more things that benefit from folks not being able to see what you're doing, there's definitely applications that the Navy's interested in that. So anyway, I think a wide variety of applications are going to come from the ocean color instrument. So looking forward to seeing what it does. All right, and our timeline has not changed. Again, we're in the middle of the contract award period right now. After that, we'll go into the mission definition review, KDPB. The KDPC is sort of a key milestone for us. That's when actually we go forward and request the congressional baseline. I will say the budget is a bit of a challenge for us in the next couple years. We're affected like you see in the news, right? With when Congress isn't passing a new budget, it's hard to get the funding where we want. So we are not forecasting any delays to the launches at this point, but until we kind of really lock in that congressional support, there's some risk of that. Next. All right, thanks. Certainly have time for questions.
All right, thank you, Pam, for the wonderful presentation. We encourage our attendees to stay on for discussion, and we especially encourage participation from the field forecast offices and regional headquarters, as well as for attendees to specify their full names in the chat room when asking a question. And there'll also be a survey that Emily will be posting in the chat, so if you have any feedback on this session or any of the satellite book club sessions, you can fill that out as well. But in a week from today, on Thursday, February 15th at 12 p.m. Eastern, we'll have Dr. Michael Fulmer, the Warning Coordination Meteorologist from the Ocean Prediction Center, and he will be discussing forecasting marine hazards with limited observations and verification. And we also encourage our attendees to contact the Tower S team, Kashad Bowman and Emily Maddox, if you have any questions about the Satellite Book Club or for any configuration of satellite products. So, and you can also follow the Tower S channel on the internal Slack workspace. But we'll go ahead and dive right into the discussion here. Looks like there's a few questions and comments here in the chat. So Tim Schmidt has posted a link for more on ABI and methane. Dan Lindsay says there's a link in there for a YouTube video. Everyone should check this out, highlighting the pre-launch process for the GOES-U launch. And there's some cool time lapses included with that. Let's see, another one from Matt Gunshore says, great talk, Pam. Maui Fire reminds me, do you know if there is an effort to make it so 1 minute meso imagery is called for significant events like that, even if a WFO doesn't call in a request?
I don't know, but somebody online might. Anybody from our team that's closer to the meso process?
This is Jordan from the National Weather Service. I don't know if we're there yet. We have our Tower S team looking into a more proactive way of looking at SPC outlooks, other places where there might be active weather, to move to task the mesoscale sectors. I believe there was a poster on it at AMS. However, I think that is not something that we're looking to implement imminently. There's a lot that would need to go into that before we transition that to operations. And of course, we always want to give the last word to our field forecasters if there's a greater need. So yeah, we want to make the most that we can of the mesoscale sectors. We realize sometimes they're not tasked when they otherwise could be, but the forecasters still have the authority to move them if they feel it's necessary. Good question, thank you.
Yeah, good questions. If you do have questions, just a reminder, you can submit those in the chat, or you can, if you want to ask a question verbally, just post that and then just go ahead and unmute yourself and go ahead and ask that. Let's see, what else do we have? Aaron Jacobs asked, how far north will the sounder provide data? Looks like he was asking about especially Juneau, Alaska, and possibly for the Anchorage WFO.
Yeah, and Andy came to the rescue with that, with the 62 north, so.
Yeah, 62 north, and it looks like centered at 105 west.
Yeah, this is Tim, so that doesn't give you any Alaska coverage, though.
Let's see.
Sorry, Alaska.
Oh, see, for TJ asking about any plans for a dense constellation of LEO satellites. This would give high resolution, large redundancy to ensure continued uptime and decent temporal resolution, assuming the constellation is dense enough. And it looks like Andy had some comments on that as well.
Definitely have the LEO guys come and talk to you too. So yeah, they're in early formulation. You've probably heard they've got a program called NEON, and they're a little bit earlier in the planning than GeoXO, but they are looking at IR sounders, microwave sounders, ocean color, vis imager. So they're in early studies, I would say, of what their plans are.
Okay. Looks like Dan Lindsay also posted a link for a map that shows the Northern Hemisphere sounder coverage in case anyone is interested in that. And let's see, for Bill, says, don't forget that the application of the LEO new caps will bring value of not only the vertical temp and moisture data, but the horizontal slices of that data for larger scale real-time info. Unfortunately, we'll miss the Arctic, and will sounder launches be on the same schedule as GOES west and east?
Right, and Andy again to the rescue. The nominally our first sounder would launch in 2035. So.
And let's see, Dr. Polly is asking, will there be any geosounder coverage over the Pacific?
Our sounder will go out a bit into the Pacific. I probably should have grabbed one of Tim Schmidt's maps to show you all of what the coverage was. I will say, in addition to our sounder, Japan is planning on flying a sounder as well. So there'll definitely be coverage from Himawari 10 when they launch, which I think is 28, 29 timeframe.
Okay. And then Brett McDonald says, I see GeoXO has plans for west, central, east. With the 4 GOES satellites, any thoughts on making west, central, east as well, or as we limited to just west and east? Would be great to have GOES central to limit horizontal parallax over the CONUS.
Yeah, at the moment, for GeoXO, the imagers will be in east and west location. That center satellite is really just going to be the sounder and atmospheric composition. We've had challenges with GeoXO just with the new capabilities, and you know, I think Congress has figured out that 3 satellites is going to cost more than 2. So I don't think we're yet stretching to the point where we're adding a 3rd imager.
And just a reminder as well, the slides will be available later today on the Tower S Satellite Book Club VLab page. You have access to that. And let's see. So a few questions from Kevin in here. Says, thank you all for the presentation, very informative. I love the simulated shortwave IR imagery resolution. And a few questions. Where can we find more information on the methane product from the GOES-R series? And also, with NexRad WSR-88D radar has developed post-processing techniques over the past 10 years or more to provide high-resolution data using the same hardware. Is there a potential to perform post-processing on the GOES-R series data to improve spatial resolution for the clean window IR and the shortwave IR imagery? And I can always repeat those if you need me to.
Yeah, on the first one, within NESDIS, Dr. Shobha Kondragupta in STAR is probably the closest to the methane research, and our plans to try to make that operational. I'm aware of, we're actually trying to hire someone that can help make that product more operational. And I will need to phone a friend for the second one. I don't know if any of our scientists want to address the post-processing question.
Yeah, Dan, if you want to go ahead. I mean, I think what they're doing with radar, I'm not fully knowledgeable of the approach they're using, but I think our options to do something similar from geosatellites are limited. Dan?
Yeah, thanks, Jordan. That's a good question, Kevin. So there's actually some ongoing work by Chuck White, who is a research scientist at CIRA, to do that very thing. Basically, he's using machine learning to learn about horizontal gradients in the 500-meter band and applying that to the other channels. And it's actually very promising. Not yet ready for prime time, but if you do a Google search of like Chuck White hand sharpening or something like that, you'll see the paper that just came out recently.
All right. There's also a few comments in here from Scott and Eric. So the sounder image posted by Dan shows coverage out to Hawaii, but Eric is asking, can the sounder coverage be shifted a little to cover the entirety of the Hawaiian Islands?
It's possible to move the satellite location. So that's actually something that's been debated a little bit within the team already. So it's possible. I noticed it's probably something we can continue to look at. There's obviously arguments for it to be further east to see hurricanes and further west to see the upstream storms.
Okay. Yeah, it looks like from some of the comments Tim has, how much of Hawaii is covered depends on just the local zenith angle. It's kind of limited. So also from Curtis Seaman from CIRA CSU is asking, will it just be one set of satellites or will there be multiples?
Yeah, good point. The program is planned with 6 satellites, so the first set of 3 and then a second set of 3 with observations going out into the 2050s.
If I could just go back to that previous question. I see there's a lot of people that are very interested in that particular topic. And we are certainly aware of that need for service equity. So we had a meeting last week. There's 3 or 4 areas, depending on how you look at them, that would really benefit from expanding our local zenith area coverage. If we shifted the satellite, we're going to cut 1 or more of these people out. Hawaii, Southeast Alaska, Maine, and the Atlantic Ocean. So I think what we're going to try to do is see if we can push our capabilities to get useful information from a little bit broader zenith angle. Europe is giving us some promise in that area. So hopefully we're able to meet the needs, at least partially, for those of you that are asking about more coverage over the ocean areas and those areas that are currently shown to be on the fringe. So we're very sensitive to all those comments. Thank you for continuing to raise them. We really wish, the Weather Service perspective, I'm speaking now, that we could have 2 sounders so we'd have fully complementary coverage with our imagers, but we're operating within the constraints that we have.
Yeah, going back to the post-processing question, it looks like there is some research that was done by Chuck White at CIRA, talking a little bit more about that topic. We also have a question from Bill asking about the parallax impacts on the sounder data.
I'm not coming to these without scientists in the future. Anyway, feel free to, science guys, feel free to jump in.
Yeah, of course, you know, anything from geo is going to have a parallax, but remember, it's not an error, it's just a difference and something to just take into account, especially when you're merging with other satellites that may have different parallax or no parallax.
There's also a few more comments in the chat if you'd like a link to Chuck's paper there. And also, looks like there are currently examples of some super resolution that have been done via a variance encoding method, which effectively provides the 0.5 kilometer resolution to other vis bands besides band 2. That's what I'm seeing here. Let's see.
I'm taking away that everybody wants more resolution and more spatial coverage. So
Yes, it sounds like, especially for Alaska and Hawaii as well. That's what we're hearing.
This is Dan again. One more quick comment on the higher resolution geocolor, like Steve just mentioned. Those of you who have the latest Tower S, and the Tower S people will have to help me out here what it's called, but basically the version that creates geocolor on the fly, that from Goes East, that actually does include this pan sharpening method that Steve is highlighting, where you get basically 0.5 kilometer resolution in geocolor. For AWIPS, well, sorry.
Yep, no, thanks, Dan. No, and I appreciate everyone's comments. Really happy to see the interest, of course, even if we're thinking about what might come next.
Yeah, it looks like there's a few more links in here of examples for the variance encoding method that Steve Miller had posted. Kevin just has a comment as well. Says, you all did too good a job with the GOES-R series and the peek at the GeoXO imagery. for operational forecasters, more resolution is one of our biggest desires. I guess that's kind of the main thing of what we've been hearing today as well from some of these comments.
Yeah.
Still have a few more minutes left if anyone has some last minute questions or comments that they'd like to post in the chat or just want to unmute themselves. And
I just, this is Jordan from the Weather Service perspective, and worked on the imager specs that will be built for GeoXO. I think our field will be pretty impressed with the incremental improvement in spatial resolution. That's been a priority for us, trying to get more bands down to 1 kilometer, getting the visible band down to as close to 250 meters as we can get. So hopefully there's something to look forward to. Yeah, I know people always want to see more, see down to that neighborhood level. But when you really think about a geostationary satellite that's 22,300 miles into space, to get the kind of resolution that we're predicting for GXI, it's a testament to the optics and American innovation to get us there.
Well said.
Can I say something? Ooh.
Sure.
Hi, this is Mike Jamalkowski, Jammer. Hi, Pam. So you had a great idea about doing future satellite book club presentations on the GXI and the GXS. And I think it'd be a good idea to do one on the OCX too, the ocean color, because I think typically the satellite book club has mostly dry side scientists and operators. And I think that the wet side needs to be represented too, even though I'm a dry side meteorologist myself. But OCX has so many advantages. It's going to be the first geostationary hyperspectral sensor, and the oceanographers, I think, are very excited about it. So I think that's something that deserves more emphasis.
Yeah, I agree. After we get the contracts award, I think it'd be a good time to come back and maybe talk about all the instruments and the details. Now that we've got a specific design, we can talk about specific capabilities. And I should say, congrats to NASA. They just launched PACE last night. So that's their LEO ocean color hyperspectral sensor. So it's LEO, so of course it's not the GEO, refresh, but the hyperspectral capability in PACE will give us a good idea of the hyperspectral capability that OCX will have as well. So we're looking forward to seeing data flowing from that.
Hear, hear.
yeah, great discussion. And especially as a aviation meteorologist, I'd be more interested in hearing more about the hyperspectral sounder and just forecasting aviation icing. So I'm looking forward to that. And I think with that, I will turn it back to Jordan for some final remarks.
All right, thank you. I saw at least 137 people today. Drew a lot of people for this presentation. So thanks for everybody for being with us today. Thanks for all the engagement. Thanks for our scientists for picking up some of the questions there. Of course, thanks to you, Pam, and our facilitator as well, Sharon, for doing a great job handling all the questions and some of the answers coming in real time. It's a real team effort today. All right, the Satellite Book Club continues next week, Thursday, February 15th. Dr. Michael Fulmer, Wording Coordination Meteorologist at the Ocean Prediction Center, is going to be discussing marine hazards with limited observations and verification. Should be great. If you have any questions in the meantime, get in touch with our Tower S team, either about the Satellite Book Club or the configuration of satellite products. You can also find us on Slack, the NWS internal workspace, hashtag Tower-S. We're always here, willing to help. Let us know how we can make satellites a bigger part of our mission service delivery. All right, thanks everybody again. Take care and see you next week.